In example 16, again, we want to identify the terms with the largest power. So the numerator, that will be negative x to the 12th, and in the denominator, 9x to the 12th, which will give us negative x to the 12th over 9x to the 12th, and we can reduce that to negative 1/9. Since we just have a constant again, the limit as x approaches both positive and negative infinity, I'm going to use that plus or minus symbol just to reduce my notation a little bit here. In both directions, that limit will be negative 1/9, which means that we have a horizontal asymptote at y equals negative 1/9, since we ended up with a numerical value for those limits in both directions. In example 17, still the same starting process. We look for the terms with the highest power. Which will give us 6x to the 12th over 8x to the 7th. And that will reduce to 3x to the 5th over 4. Then we'll consider the limit of that expression as x approaches infinity. Since we're plugging in positive values, that will be a positive value raised to an odd power. So that stays positive over 4. And our limit as x approaches infinity will be positive infinity. If we take the limit as x approaches negative infinity of 3x to the 5th over 4, we'll get 3 times a negative value raised to an odd power, so that'll stay odd, divided by 4, and then we'll have an positive times a negative, which will make that a negative infinity. Since our end behavior is going to infinity on both ends, there's no horizontal asymptote for this function.